After encoding decoding process, let's just go to the second branch in the cryptography, which is called as encryption, and the reverse process is called the decryption. Right, as we have seen, in encoding we generally translate the data from one character from one language to the another language which have its own character sets. So it's just a simple translation, like from English to Hindi, English to French, Japanese, Chinese, any language. So they have their own character sets and we are just translating from one character set to the another one. That's a simple translation and we call it as encoding decoding. Simple one. And the common example, the simplest example, we can take it as from binary to decimal, or you can take it from, let's say, binary to hexadecimal. Right, these are simple example for the encoding decoding flows. Right, now if we talk about encryption decryption, it is mainly used for the security, for just to maintain the confidentiality of the data. We use encryption decryption process. So in encryption we convert the data into a non-readable format. Convert data into non-readable format. But this non-readable format is only for the unauthorized person. If the user is authorized, they can perform the reverse decryption process and they can read the data, right? But unauthorized person cannot read the data. And if we talk about encryption decryption and in respect of authorization, we are talking about a key. So in encryption decryption, a key is used to define, just to validate that the user is authorized or not. Right, if user has the key, he is authorized. If user don't have the key, he is not authorized. Simple as that. Now we have seen that we have encryption decryption and for that we need a key. Now there must be a standard algorithm which we gonna use for the encryption decryption, similar to like encoding decoding. We have UTF-8, we have ASCII, we have base64. Right, so encryption, we will talk about encryption and the reverse is called the decryption, so we will only talk about the encryption here. Encryption has two main types. The first one is called the symmetric and the second one is called the asymmetric. Now the main catch arises here. In case of symmetric, we only have a single key, right? But in case of asymmetric, we have two different keys. First one is the private key, and these two different keys are automatically derived by the system itself with help of the algorithm. Right, so you cannot define your own keys in asymmetric, so these are automatically derived by the system. Right, the first key is called as the private, second key is called as the public. Right, in asymmetric we got two keys. The private key is always kept on the user side. Right, the person who generates this key will get the private key, and the second key is public, which will be shared to everyone, or the shared with the receiver of the data. Right, so this shared key is known for the authorization actually in the case of asymmetric, so it's shared with everyone. Done, simple case. Now if we talk more about the difference between symmetric and asymmetric, symmetric is a bit faster as compared to asymmetric. Right, symmetric is faster. On the other hand, asymmetric is slow. But if we talk about the privacy and the level of confidentiality that both of these type of algorithms provide, so if we talk about the symmetric is weaker if we compare it with the asymmetric. It's not actually weak. If we talk about the real life, it's not actually weak. If we compare it with the asymmetric, only then it's weak. Comparison with the asymmetric makes the symmetric weak, but in actual symmetric is not weak. Right, so if we compare asymmetric, it's stronger than symmetric. Just write it here as well, weaker than asymmetric. Right, so now the question lies, which particular type of encryption we should use in our regular day-to-day life, or for the application that we are developing, right? Let's take a simple example. Let's say I'm using a general website, right? That website runs on HTTPS. Now in HTTPS, the S means that we are using SSL TLS here, right? SSL TLS is just a standard way to implement encryption over the traffic, right? Now for the encryption in SSL TLS, we actually perform the encryption with help of symmetric, right? So the actual encryption is performed with the help of symmetric because it's faster, right? So if you want a faster way to perform the encryption decryption, you can go with the symmetric. But if you want the more secure method for the data, you can go with the asymmetric, right? Now let's take a simple example for that. Suppose I'm using, let's say suppose two friends are talking. First one is the Ram here, second one is the Sham here, right? And they are talking with help through the WhatsApp, let's say, right? And we can see that WhatsApp always provide end-to-end encryption, and that end-to-end encryption is done with help of, let's say, AES, right? So we are using symmetric algorithm here. And one more thing, that negotiation of algorithm, like which particular algorithm we gonna use, is generally called as the SSL TLS handshake. So it's just a negotiation for the algorithm, which algo they're gonna use and what key will be used for those algorithm, right? Let me just give you simple examples as well. For symmetric, we use AES algorithms widely, and for asymmetric, we use RS. We'll take examples for that as well, right? But just keep it in mind, for symmetric we will use AES, for asymmetric we use RSA. Now if we talk about symmetric, RAM will generate a key. RAM can pick any key he wants. Let's say if he wants a key like this one, this is also allowed. But if RAM wants to use asymmetric, then that key will be derived by the system. He cannot pick the key from his own, right? But because we are using symmetric here, we can pick any key. This key will be shared to the Sham, that okay, we're gonna use this particular key for the encryption, right? Now, if there is a middleman, for example, let's say WhatsApp gets compromised, right? The whole communication is through the WhatsApp here. The whole communication passes through the WhatsApp, right? We can add it right here as well. Now, if WhatsApp gets compromised, I'm just taking as attacker here, right? Let me just write WhatsApp and let's place it here. Okay, if in any case, if in any chance WhatsApp servers get compromised because of any particular vulnerability, because of any particular OS level vulnerability, service level, could be anything, but if WhatsApp server get compromised, that attacker can access this key which is shared between the RAM and the Sham, right? Because it's traveling in a plain text, right? So to avoid these kind of scenarios, we usually use the asymmetric algorithms as well. So what RAM will do before sharing the key through the WhatsApp to the Sham, what RAM will do, instead of directly sending it in the plain text to the Sham, RAM and Sham will negotiate on the asymmetric first. That okay, we're gonna use asymmetric, and for asymmetric, let's say they negotiate on RSA, right? So what RAM will do, RAM will generate two keys. First one is the public and second one is the private. RAM will keep the private on his side and send the public to Sham. That public key is sent to the Sham. Let's just send it right here. Now, after getting the public key from Sham, what Sham will do, Sham will use that public key and encrypt the AES key and send it to the Sham. Public RSA key. With help of public RSA key, RAM sorry, with the help of public RSA key, Shyam will encrypt the AES key which he just derived and send it to the RAM. Now, for asymmetric, the actual security adds here. For symmetric, if you have performed the encryption with the private key, for encryption, let's say you have used the private, right? You can only decrypt it with the public. Right? And same is for the reverse process as well. If you have performed the encryption with the public, you can only decrypt it with the private. That's how it usually works for the asymmetric. If you have performed the encryption with private, you can only decrypt with the public. If you have performed the encryption with the public, you can only decrypt it with the private. Simple flow, right? And in our case, as Shyam has used the public key to perform the encryption, only RAM can decrypt the key because private key is only available to the RAM. It is never shared, it's only available on the RAM side, right? And that's how the actual AES key is being shared between RAM and Shyam to perform the secure transaction, right? So actual encryption is done through the symmetric, but to securely share that symmetric key, we usually use the asymmetric as well, right? Now let's take a simple example how this AES or the RSA encryption looks like, right? Let's take a simple example of it, and for that let's just use it here. So this is a simple platform where you can check online RSA and AES parts as well. So let's say I'm using a simple message. I'm just writing, hey buddy, to the Shyam. So let's say this is the RAM side, AES encryption, and this is the Shyam side where he will decrypt the message, right? So we have different modes of operation in each encryption side, for the RSA, for the AES, for symmetric, asymmetric, both, right? We'll discuss this mode of operations later. Now we are using PKCS5 padding as well, just to complete the block size, which we will discuss again later here as well. And we are only using 128-bit key size, which we will discuss again later here as well. So let's keep the key as 128 and then 821 again, same, right? And the output would be base 64 encoded. Let's perform the encryption, and this is the encrypted message which will be sent to the Shyam. So if I talk about the message here, after getting the key, he will type the message, and the message is this one. This is the encrypted message. Right, and actually this particular message is sent to the Shyam. Now when Shyam will get this message, he will use the AES key to perform the decryption, right? This will be sent directly to the Shyam. Let me just remove this arrow for better understanding. You will not be confused that it's passed to the public key, right? So here we perform the AES decryption, and decryption is performed with the key that is derived on the Shyam's end and shared with the RAM, right? Same key will be used for encryption and decryption, right? And again, let me just attach it to the RAM there for a better understanding. Where is the, let me just delete it then. RAM will generate the message and send it to the Shyam, right? So this will be the general flow, right? If we are using WhatsApp, the sender and the receiver, RAM and Shyam, first they will negotiate on the encryption algorithm that will be used. In this case, AES is actually used for the encryption decryption, but because it's a symmetric cipher, symmetric algorithm, In symmetric we use single key, and to safely secure that symmetric key they're gonna use RSA. So RAM will generate two keys. First one is private, second one is public. This public key will be shared to the sham here, right? After receiving the RAM's public key, sham will generate a AES key and encrypt it with the public key received from the RAM side, and then send the encrypted message to the RAM. Encrypted AES key, right? When RAM will receive the message from sham, it will be decrypted with help of the private key, right? After getting the key, now RAM will write a message, encrypt it with the AES and send it to the sham. After getting the message, sham will decrypt the message with the key which he just derived, right? And this message flow will keep on going. This negotiation will only happen once when you establish a connection. So this encryption decryption will keep happening, but the negotiation only happens once. It will not happen again and again. So first they will exchange the key, and they don't exchange the key up till the session is active, right? If the session has terminated, then they will again negotiate, and then the same process will flow again and again, right? Now if we talk about the encryption algorithm like AES and RSA, there are few things that we have to keep in mind. The first one is, for each encryption algorithm, again there are two different types of encryption algorithm as well. Let's just discuss those as well. So we have two types of encryption. Let's start with that one. So I'm starting with types of encryption. We have two types, symmetric and asymmetric. For symmetric, the common algorithm that we use is AES. There are again different algorithms as well, but AES is widely used, so I'm just taking with AES as well. And for asymmetric, we have RSA. Right now, if we talk about the types of encryption algorithm, these are the types of encryption. If we talk about types of encryption algorithms, we're not talking about the encryption process, we're talking about the particular algorithm that will be used in encryption or decryption. It could be symmetric, asymmetric, anyway, right? But these are just types of algorithm. Here we have two types again. First one is the block ciphers, second one is the symmetric ciphers, stream ciphers, right? In case of block cipher, they can only encrypt or decrypt fixed amount of data in a go, right? If you take the example of AES and RS, let's take the example of AES. It's 128. They can only encrypt 128 binary bits in one go, right? On the other hand, if you talk about the stream cipher, they can take a range from, let's say, 1 to 128, right? And the common algorithm which is used by the stream ciphers, and one of them is CHA, CHA 20. And the second one is SALSA, SALSA and 20. These are the two common stream ciphers, and their block size can vary between the range. They can go for 50, 55, 59, 69, 99, 89, 81. They can pick any number between this range, right? But for the block cipher, they always need the exact 128 binary bits, not less, not more, exact 128 binary bits, right? If we don't have 128 binary bits, for example, if we take, let's say, the message is only hello, right? And for example, let's say we are using ASCII or UTF-8 character sets. Each character will take 8 binary bits, right? And we have 5 of them, so we only have around 40 binary bits, right? But all we need is 128. So we have to complete this 128 binary bit block. And to complete that, we use padding here, which we just saw that we are using PKCS5 padding just to complete the block size here, right? We use the paddings. Now, after getting these two types of encryption algorithm about the stream and the block, now let's move toward the main characteristics of the algorithm. We will only discuss about the AES and the RSA. So let me just put it right after that. If we talk about AES, there are few things that we needs to know. Let me just put it here. We can keep it here and branch it. Okay, so the first one is the block size, which is 128 binary bits. Let me just write it here. Block size is 128 binary bits. The second thing we need to know about any encryption algorithm is the key size, right? So for the case of AES, we have three main size. First one is 128 binary bits, second one is 192 binary bits, and the third one is 256 binary bits. Now, one thing that you should know about those key sizes: larger the key size, stronger the encryption output, right? And the encryption output is called as the cipher or ciphertext as the output. The encryption algorithm is called the ciphertext. Sorry, the encryption algo is called the cipher, and the output is called the ciphertext. These are again common two terms that you should know about, right? Now, for AES, we have three different key size: 128 binary bits, 192 binary bits, and 256 binary bits, right? Higher the key size, or let's say larger the key size, better the encryption, right? Now, other than this key size and block size, there is one more thing that we should know about the encryption, specifically for this AES and its predecessor, that is DES. But AES is far better than DES. We are not using DES anymore. AES is widely used. So the third thing is number of operations. So this is not something that we can control. So it is again automatically performed by the encryption defined algorithm. So this is not something under our control, but it again varies based on the key size. If we have used the key size as 128 binary bits, it will perform 10 operations, 10 same operation. The operation will not be different. It will perform 10 same operation on the data, right? If we use the key size as 128 binary bits. If we have used 192, it will perform the same operation 12 times. And if we use the key size as 256, it will perform the same operation 14 times, right? So if we perform more operations, it will consume more memory, it will consume more time, but it will gives us a stronger output, stronger ciphertext as well. So if you want to use a stronger output, stronger encryption, you have to choose a larger key. So again, larger the key size, more operation it will perform, and more complex output you will get, right? That's the simple thing that we should know about. So this is for 128-bit key, for 192-bit key, and 256-bit key, right? These are the three things that you should know about: the key size, block size, and number of operation, right? Same thing, the main part about the RSA is the key size. And if you talk about the key size in RSA, we have again a range. We can check it right here. So for RSA, the range varies from 515 binary bits to 4096. You can pick any size from these 5 options that are available on this platform, right? You can do the same thing with your terminals as well, with any language as well. Libraries are available. So you can pick any key size. And these keys are not user defined, they are automatically generated by the system with help of the algorithm, right? For the AES, for the symmetric encryption algorithm, you can pick your own key, but for asymmetric, key will be automatically derived, right? Now again, these keys are base 64 encoding, and if you want to decode them, so let's say base 64 decode, and if I try to decode it, these are not something readable if we go for the UTF-8 character set. So these are just this could be a random keys as well, but it's not actually random, they are mathematically computed, right? But they are not printable or readable characters, right? So this is the key that is derived by the RSA encryption algorithm. Now for example, I'm performing the encryption with the private key, with the public key here, right? Let's say this is my message, hey bro, and I'm sending it to Shyam, is as per our example we have seen here, right? Ram and Shyam are communicating, they are not using AES for the encryption, let's say they are using RSA this time, right? And they are performing encryption with the public key. So if they encrypt the message, this would be the actual message which will be sent to the Shyam, and this is a very long message, right? But these asymmetric encryption algorithms are way stronger than symmetric encryption algorithm, but because they consume more memory, more resource and more time, we prefer using symmetrics over asymmetric, right? And if we have encrypted with this public key, we can only decrypt with the private key. For example, we are able to decrypt with the private, but if I use the same key here, I have used the public key, I cannot decrypt the message. So if you encrypt with the public, you can only decrypt with the private, right? Even if you select any private or padding, it will not be changed. Now, after this key size for the encryption algorithm, there are few more things that you should know about, and that is modes of operation. Let me just put it right there. Okay, after that, let's just talk about modes of operation. So modes of operation again defines how your input will be processed by the encryption algorithm. It could be AES, DES, anything like RSA as well. So it just defines the way how your input will be passed to the encryption algorithm. That's all what it defines. And we have a different list of modes of operation here as well. So if I give you a simple list, so these are the few common algorithms or few common mode of operations defined for symmetric, let's say, right? So for the AES, we have, let's say, ECB, we call it electronic code book, which we have used here, ECB. You can pick any one of them. So they just only change the way your input will be passed to the function, right? So for ECB, electronic code book, we will pass the plain text, we will pass the key, encryption algo will do its work and gives us the output, right? It will only process 128 binary bits in a single go. After that, it will pick the second block out of it. If we talk about the CBC, we have to pass the IV, the initialization vector, with the key, right? First, our plain text will get XORed with the IV, then it will be passed to the key. If I give you a better picture here, you can see it here, right? This plus symbol within the circle represents the XOR operation. So plain text, our input, will get XOR with the IV, then passed to the encryption function, which will take the key and perform the ciphertext. Now the ciphertext from the first block will become the IV for the second block here, and the same process will keeps on going here, right? After CBC, we can also check for this PCBC, propagating cipher block chaining. There are multiple modes of operation, and they only change the way your operation, your input will be passed to the algorithm, right? So for example, here we will pass the IV, and the same thing is going on, but instead of passing the ciphertext directly to the second block, we will XOR it again with the plain text and then pass it to the second block of data, right? And just to show you one more, like this one, if we talk about the CFB, cipher feedback mode of operation here, in this case, the IV is getting encrypted. Our plain text is not encrypting here, only IV will be encrypted with help of the key, and the output will get XOR with the plain text, and the final output will be the ciphertext. So they only define the way your input will be passed to the algorithm. That's how it usually works. And we have few more if you want to more. Let's say this is output feedback, the same thing, but if for the second block we pass the encrypted IV instead of plain text, right? And there is one more, the counter. In this case we have to pass the key and we will start a counter with the nonce value. So in this case nonce is again similar to the IV, but nonce, the size of the nonce is smaller than the IV, right? And for these operations the size of the IV will be equivalent, will be equal to plain text, and the size of first block plain text is 128, right? So the size of IV and the first block plain text will always remain the 128 binary bit. The size of IV is 128 binary bits if anyone asks you. Now if we talk about the CTR, we have a nonce value, then we start the counter. That's the first block, then the second block, then the third block. So counter will keeps on incrementing by 1, and the nonce will remain the same, right? But again we are not encrypting the plain text, we are only performing the XOR operation over the encrypted nonce and counter value and then getting the ciphertext. So that's how it usually works with different modes of operation that you can go with. So we have seen few of them, like ECB is one, CBC is the another one, counter is another one. So these are the few common modes of operation that you can check, or if you want to learn more about this mode of operation you can directly Google it and read more about them. So that's all about the encryption decryption flow, and see you in the next session.